Hi everyone, can't be there with you on this Friday, but I do expect everyone to be in their best behavior, on their best game, and work through these questions that I've provided to you through the substitute. Okay? 6.7. Basically, by this point in time, we have all the tools we need to navigate any kind of question that is quadratic. All right, so we're going to try some. There are 7 questions in total, and I'd like you to try 1, 3, and 5 with me because they sort of summarize the kind of questions you might see. The kind of questions you get in grade 10 are fairly generalized. They are very predictable, actually. And so if you get very comfortable with certain styles or know how to pick up keywords, I think you'll be in a much more comfortable situation. Now, before we get into it, remember, you'll need 1, 3, and 5. And seeing as how there's no space on this sheet, you might want to take out a piece of paper. Before we start, I'd like to take a look at our Brightspace. And looking here, we are in Friday, right here. Come Monday, it's Victoria Day, but when we come back, there is no review day. You're going straight into an assignment day. It is going to be a 2-day thing. You are not allowed to take it home. So once you complete it, you will hand it in to me for day 1. And then when you come Wednesday, I will give it back to you and you will continue it. You're expected to finish by Wednesday. If you are absent on any of these days, I'm not sure what else I can do for you other than to provide you an opportunity to make up for it. But know that it's not something that you should take lightly. It is going to be a fairly extensive assignment. You could think about it as an open book test. It's not as much super crazy T questions, but you do have to know your stuff. Now, what kind of stuff do you need to know? Let me try to break it down for you. I already copied numbers 1, 2, 3, and 1, 3, and 5, so ignore that. But the kind of things that you might want to prepare yourself for this assignment as you practice chapter 6.7 is terminology, like standard form versus x-intercept or factored form versus vertex form. What do these forms look like? Although they are all different variations or different looks for a quadratic equation, that is ax squared plus bx plus c. That would be in standard form, but it can also be provided in factored form. It could also be provided in vertex form, right? These are things that you should know and be very comfortable sort of throwing around as part of your word answers. Okay. There's some other things that you should know, so you might want to take note, and you can use this video as well. Key features, like if I were to ask you for x-intercepts, if I were to ask you for y-intercepts, if I were to ask you for axis of symmetry, or rather line of symmetry, or if I were to ask you about vertex itself. These are key features of a quadratic equation, rather a parabola, and you should be able to not only be able to talk about it, but you should be able to find it depending on how I present it to you in the equation. I talked about this earlier too for your previous quizzes and whatnot. But if I give you this standard form or x-intercept form or vertex form, you should be able to turn it into a graph. You should be able to draw it. For example, if you're given in standard form, I would turn it into a factored form to find my x-intercepts. And using these x-intercepts, I could find my line of symmetry. And using my line of symmetry, I can plug it in and find out where my vertex happens to be. Like if it's here, I know my parabola looks like this. If it's down here, I know my parabola looks like this, so on and so forth. Another way you can do it is using the vertex form. I can complete the square and figure out exactly where the vertex is, dot, 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 dot. And maybe use accuracy points or just plug in a y equals 0 to figure out what the x could be. There's a variety of ways I could solve, and there we go. Okay. And of course, if you can get the equation and create a graph, you should be able to do the exact opposite If I give you a graph, you should be able to give me an equation for it. Okay, that seems like a lot, but maybe if I could list it out, you'll feel a lot better about it. What are some things you need to know? Number one, terminology. Ology. My goodness, terrible. Okay, so that would be standard form, vertex form, x-intercept form. You should be able to identify key features of a parabola, such as x-intercept, y-intercept, axis of symmetry, and maybe vertex. Okay, and also be able to calculate it. How would you calculate that? Well, it would really help if you knew, because in doing so, you should be able to graph it given an equation in, oh my goodness, in any form. You should be able to graph it in any form. And if you could do number three, hey, given the graph, give the equation. You should be able to do it in reverse. Okay. The last one I want to talk about is, you remember in class I really emphasized how there's not enough time for me to teach you every single tiny detail and dot connecting to another dot because there's too many dots to connect. And so with all the things we learned, I encourage you to practice as much as possible so that you can start connecting your own dots. Okay, so large blanket ideas that blanket over the general concept of quadratic formula or quadratic equations. Okay, so blanket ideas that test your true understanding, I guess. So for example, if you remember when we were talking about the quadratic formula, do you remember me saying, hey, if the discriminant, like if this part, b squared minus 4ac, is what gives me the 2 points and I have to square root something, what would I get if there are no x-intercepts possible, right? Or if I have a parabola that does this, what would you expect to come out of here? And the idea is you would get a negative value. You would not be able to solve it. Like these things like that, I don't specifically teach, but we sort of encountered it as we did more and more questions. And so I hope that through your practice, you are able to connect these dots and more dots, the things that we might not have talked about specifically. Okay, so that's about it. And so I am, without further ado, let me move on to today's lesson. I am going to do questions 1, 3, and 5. I don't expect you to copy all this down, but maybe when you get home, you could look at the video again and take note so that you can study or prepare for the assignment day 1 and day 2. Okay, so here we go. Word question 1, the standard typical quadratic word problem that you would see basically in any school. Jason jumped off of a cliff into an ocean in Acapulco while vacationing with some friends. His height could be modeled by the equation blah blah blah, where t is the time in seconds and h is the height. Something like that. So time passes. So I'm assuming this is where the person is, okay, and it's on a cliff. And as time passes, the height goes lower and lower and lower. But because time isn't gonna stay at 0, right? Time continues to increase. So the parabola that we draw will probably look something like this. Now, I don't know if the person jumped or if they just sort of started falling off. But I'm going to draw it like this in hopes that it is correct. Here we go. How long did it take for Jason to reach his maximum height? Right away, I'm thinking maybe I drew it wrong. Maybe he does jump to reach a maximum height before falling. But let's investigate. How will we take this and find the vertex? You got 5 seconds. 4, 3, 2, 1. I'll give you 2 options. Number 1, you can complete the square to find the vertex right away. A long way to do it is you can find the x-intercepts that are involved, find the axis of symmetry using that, and then plug in the x value to find the y value. Okay, so just because I want to exercise my skills, I am going to pretend we will complete the square. Okay, so let's use a different color pen here. Let's use a blue. And we have h is equal to negative 16t squared plus 16t plus 480. It's an old habit I have. I never leave the equation as is. I always write it down because I don't want to keep on looking up and then writing and then looking up and writing. Okay, I feel like that's actually less efficient. So here it is. This is my question. Since I want the vertex, I am going to complete the square. What does that mean? I will take the first two terms together and leave the last term, right? So essentially, I'm basically completing the square. This is t plus something, and I have a t plus something. You know what I'm talking about. Here we go. Next, because I have an a value, I will factor that out. I want my a value I want my t squared term to actually have no coefficient. So that would be t squared minus t plus 480. Next, I will do my little shortcut cheat, take this term, divide by 2, and square to find my constant term. Negative 1 divided by 2 squared, 0.5 squared is going to be positive 0.25. I know that seems a little weird, but with your practice, I'm sure you'll be able to rise above it. From here, I know, one thing, I added a positive 0.25, so I am going to have to subtract 0.25. I don't like that fourth term because I actually like my trinomial as is. So I will keep my trinomial here. Okay. And remove the fourth term from the bracket, which is not actually negative 0.25. It's negative 0.25 expanded multiplied by negative 16. It is going to be a plus 480. So this I know because I completed the square. It is a perfect square trinomial, which means this will be t minus 0.5 and t minus 0.5 plus 484. My vertex is now within grasp. My h is 0.5. My k is 484. Therefore, vertex is 0.5484. My maximum height is 484. Oh, and it's reached at 0.5 seconds. So how long did it take for Jason to reach? It took Jason 0.5 seconds. Caitlin's going to be mad at me. I need the therefore sign. There. Okay, that's part A. What was the highest point that Jason reached? Oh, I already answered it, didn't I? Well, one good thing about the vertex form is that it already tells me. What was the highest point? So part B, the highest height was 484 meters. Done. Part C, after how many seconds did Jason hit the water? What does that mean? That implies height is going to be a 0. If 0 equals negative t squared plus 16t plus 480, I guess it's up to me to just factor that. Should we attempt to factor this negative 16 times 480 and find two numbers that multiply to that but add to a 16? I don't think so. I'm actually going to see if I can factor out the negative 16, making my trinomial easier. 30. Oh, perfect. Yes, this is factorable. Negative 16. Two numbers that multiply to negative 30, but add to a negative 1. Very simple. It's negative 6 and positive 5. If I decompose, this becomes negative t plus 5t minus 30. Negative 16. This becomes t times t minus 6. I'm factoring out a t from the first two terms. I'm going to factor out a 5 from the last two terms. And if I'm doing it correctly, my bracket should be exactly the same. T minus 6, t plus 5. And there it is. When is the height equal to a 0? Height equals to a 0 when time equals 6 or time equals negative 5. Obviously, we're not going to go back in time. We don't have, well, it's a very nonsensical answer. So we will consider this as a rejection because it is an extraneous error. Mathematically, it is good, but realistically, it is not good. That's an extraneous root or extraneous answer. So I will say, therefore, I didn't forget this time, therefore, is there a person's name? I forgot the name already. Jason hits the water 6 seconds after jumping. There it is. Very standard quadratic question. Okay. I'm not sure how much time students would take to copy this down or just sort of process it. So if the substitute can pause the video here and give students a chance to maybe look at it or put a little note here saying, I don't get this part, I'm going to ask him later. Okay, that would be great. Okay, I will move on. Assuming that you've paused already, I will move on. Question 3 is a geometry-based question. So it will involve area. So area of a rectangle is length times width. Area of a triangle will be half base times height. Area of, I don't know, a circle would be pi r squared, so on and so forth. It always has some kind of two variable system going on, or a variable multiplying with another variable. Let's see. The hypotenuse is a right triangle. In a right triangle is 13. Okay. Straight off the bat, I am going to draw myself a right triangle because it helps. The hypotenuse is 13. Great. Of the other two sides, one is 7 centimeters longer than the other. Let's, determine the lengths of those two sides. So in geometry questions, they don't give you a equation, which means you have to create one. That means you need your let statement. Let x represent one side. The question says one side is 7 centimeters longer than the other. So let x plus 7 represent other side. Because the difference is 7, you are more than welcome to say it could be x and then x minus 7, so that the x is the larger number and x minus 7 is a smaller number. But that is your prerogative. I'm just going to do this because I like addition more. Here we go. X is here, and x plus 7 is going to be there, only because I drew it that way. Determine the lengths of these two sides. Okay, what could we do with this? It doesn't give me any information for area, does it? However, the key is the hypotenuse of a right triangle. By now, we all know the side lengths right triangle theorem, whatever you want to call it, is a squared plus b squared. That implies 13 squared is equal to x plus 7 squared plus x squared. Ooh, we gotta solve this? That's right. But if you use your head a little bit and sort of mentally expand this out, you know this is going to be some kind of x squared trinomial. This is going to be another x squared you are adding. and this is just a regular number, you will be able to get some number equals some quadratic. If you want to solve that, it's going to be your good old set one side equal to a 0 and find x. So let's try it. I'm going to work this out. 13 times 13, 169. Multiply this out in my head. It becomes x squared. X times 7, 7 times x, 14x. 7 times 7, 49. And this is plus x squared. Okay. X squared, they're going to add together. Also, I don't want this number. The question is, what is the value of x to make the y value a 169? That's annoying. The only tool we have is if we have our trinomial equaling a 0, because then we can use factoring, or then we can use quadratic formula. Right? This doesn't help us, so let's manipulate it. Subtract both sides by 169. X squared plus x squared is 2x. 14x is here. And then subtract both sides, we get negative 120. These numbers don't look fun. I'm going to see if I can factor out the 2, giving me x squared, 7x, negative 60. Can I find two numbers that multiply to 60 but add to a 7? I think I can. Negative 60 and a 7. I think the answer is 12 and a negative 5. But let's pretend you can't get that. How about we try quadratic formula this time? Okay, so we've got, since this is my quadratic, I don't have to worry about the 2. My a value is a 1. My b value is a 7. And my c value is a negative 60. For this, the root of this equation is going to be x equals negative b plus minus b squared minus 4 times 1 times c. And over 2a. Oops, sorry about that. Let me close my Discord. Not necessary. And continue. This is x equals negative 7 plus minus. This is positive 240. Looks like it's going to be 289. If I remember correctly, I think that's a 17. Square root 289. Yep, that's 17. So my roots are going to be negative 7 plus 17 divided by 2. That's 5. Or negative 7 minus 17 divided by 2. Negative 24, negative 12, which is my two numbers. Great. So here we go. Since I have my x-intercepts for this equation, I also have the roots for that equation. What am I saying? It means, when will the hypotenuse of 13 be created when you have a side and a side plus 7? X could be 12, or x could be, x could be negative 12, or a positive 5. They both are acceptable mathematically, but in real life, that doesn't make any sense. Like, when would you ever have a side length of negative 12? That's nonsensical. So negative 12 is going to be rejected. It is another extraneous root. It works mathematically, but it does not work when applied to this situation. So my x is a 5. What does that mean? Therefore, side lengths are 5 and 5 plus 7 and positive 12. There it is. Ta-da. Geometry. There are situations where you will have to pull formulas from other circumstances. So it could be Pythagorean theorem, it could be area of a square or a rectangle, it could be area of a triangle, it could be area of a circle, it could be area of anything really. So be prepared. I will not provide all of them, but there will be some that will be given to you on tests. As for being prepared for your assignment, it should be somewhere in your notes. Create something over the weekend if you are scared that you will forget formulas. Just write any area formula that you think you might need. Okay. Once again, I will ask the substitute to pause the video if necessary. And yeah, we'll move on to question 5. Okay. So assuming you've done paused, here we go. Question 5. This is a very popular style of quadratic question that has been tested and true, really. It is a revenue equation that you have to create, and they give you some cryptic situations, so you're going to have to read it very carefully. I'm sure I've asked you this before as a class, but the question is, Business 101, how do you calculate how much money you can make? And typically, the very basic formula you get is, well, first you figure out how much money you are selling something for. So what is the price of your item? Okay, and then multiplied by how many items you sold, right? So if your price for, let's say, artisan apple pie that you bake at home is $10, and you sold 100 of these, 10 times 100, you made $1,000. Okay, that's what I mean. So we're going to use this template to help me calculate revenue. It says last year, talent show tickets were sold for how much? $11, and 400 people purchased them. So last year, the revenue was 4,400. Good money. It has been determined, though, this year, every $1 increase would decrease the attendance of 20 people. So if the price goes up, the number goes down. Okay, which sort of makes sense. What ticket price would maximize revenue? Oh, okay, I'm already starting to get keywords. Maximized revenue. Revenue is the Y value. In other words, I'm looking for vertex. I need to create an equation to find the vertex. So let me lay it out. Revenue is supposed to be 11, but if I made it plus 1, don't write this down, then 400 would lose 20 people. If I made it plus 2, 400 would lose 40 people. And if I made it plus 3, you would lose 60, so on and so forth. How do we convert this as an equation? Well, 1 to 20, 2 to 40, 3 to 60. Every time this goes up by 1, this goes down by 20. You can argue then, and this is very typical, every time I increase by 1x, I subtract by 20 of the same x. So if x is 1, that's 20. If x is 2, that's 40. If x is 3, that's 60. I hope that makes sense. Here is your quadratic formula. Your goal is to find the vertex so that I can find the maximum R value or maximum Y value. Okay? So what are some ways you could do this? You could multiply this out to get an a squared plus bx plus c, and then complete the square. But I'm actually going to cheat a little bit. What are the x-intercepts? If I can find the x-intercepts, then I can find the middle, the axis of symmetry. And knowing the axis of symmetry, I can just plug it in and find the y value. And by the way, sorry about that. It's going to look something like this. Okay? So, when is revenue equal to a 0? Well, let's put it as a 0. If that's equal to 0, then this bracket or that bracket has to equal a 0. So 11 plus 1x. If 11 plus 1x equals to 0. That means x equals to negative 11. That is one of my x-intercepts. If 400 minus 20x is equal to a 0, then negative 20x equals to negative 400, and x equals to 20. 20 and 0 is my other x-intercept. Okay, so that's negative 11, and that's 20. Where's the middle ground? Well, I don't know. I'm going to average it. So the axis of symmetry is going to be the average of the x-intercepts divided by 2. That is 9 over 2, which is 4.5. My axis of symmetry is going to be somewhere here. Okay, great. So where's my vertex? Remember, this means my vertex x value is going to be 4.5. I can find my revenue by plugging in 1 times 4.5 and 400 minus 20 times 4.5. I can just plug it in. Guess what? This is 15.5, and this is 40, 80, 90. 400 minus 90, 310. Excuse me while I plug this into the calculator. 4805. 4805. My maximum revenue is $4,805. It is $400 more than last year. So if I were to raise, so I'm just going to do a full sentence, even though it doesn't ask me for that. What price would it? I guess it does. So if I raise the price by 4.5, we would maximize the revenue. What does that mean? So what is the price? Remember, that first bracket represented the price per ticket. So my price would be 15.5. The maximum revenue will be generated if the ticket price is $15.5. Oh, $15.50. $15.50. And that's it. That brings us to the end. Okay, these questions, particularly the revenue question, is one that teachers like to ask a lot. Because not only do you have to create an equation, the creation of that is confusing because it seems like you already have something. But no, 11 and 40 are only parts of the real thing. So we like it. We like it a lot. I'll bring this back down here and wait for the substitute to pause the video in case the students need it. But otherwise, I hope that you will give yourself the opportunity to suffer a little bit and work out all of these questions. Please do so. Be prepared for Tuesday and have a good long weekend. Okay, once again, suffer well. We will see you after the weekend. Bye.